Hello everyone. Welcome to our overview session on user experience and the design thinking process. In this session, we'll spend time on exploring how user-centric design can revolutionize even the most complex systems. We will take one end-to-end example of a public transportation network and try to apply our learnings on it. But feel free to take your own example and follow the process. During the session or the end of the session, do comment if this short video has helped you to learn something, to keep me encouraged to put more videos like this in future. Whether you're a UX professional or simply a design enthusiast, there's something here for you. So stay tuned before we begin. Let's try to define user experience. UX is the total experience a person has when interacting with a product, service, or environment. From the usability of an app, to the visual design of signage, to how well it meets user goals and emotional needs. A well-crafted UX aligns features and navigation with how people naturally think, minimizes friction so that key actions are quick and straightforward, and creates aesthetically pleasing interfaces that also serve a functional purpose. To structure our approach, we rely on core UX principles and guidelines. Let's look at them one by one next. Usability, which means efficiency, learnability, memorability, error tolerance. For example, for city transport, the bus schedule or route map should be easy to grasp. Accessibility, which means color contrast, scalable text, and alternative ways to convey information. For example, ensure riders with visual, auditory, or mobility challenges can use bus services. Consistency, which means uniform layout across station kiosks, signage, and mobile apps. Feedback, which means providing immediate responses for user actions. For example, a bus kiosk showing arriving in 5 minutes, or an app push notification if a delay occurs. Simplicity and clarity, which means minimal text, icon-based road representation, and intuitive color coding. For example, avoid overloading users with extraneous details or complex instructions. Credibility and trust, which means match between system and real world. Keep real-time data accurate to maintain user confidence. For example, in a city bus system, if official signage says bus 12 departs 5:10 p.m., the app must also reflect the same info. Update if delayed, never contradictory. So do you really think UX can play a role anywhere? Let's find out what value we get through an improved public transport system. Why promoting a public transport is important. Because this will help encouraging more people to choose public transport over personal vehicles, easing traffic, improving air quality, and overall city life. Also, a well-designed bus stations and tools reduce commuter stress, crowding, and uncertainty. But this will only be possible if there is a great user experience when using public transport. But how to create a great customer experience? Wait, are we really thinking of improved user experience or indirectly about an improved brain experience? Let's find out. Study says our brain responds to a visual data better than any other type of data. In fact, the human brain processes images 60,000 times faster than text, and 90% of the information transmitted to the brain is visual. Which means we need to understand how a human brain interprets UI elements. So, let's deep dive further into another set of core principles which are related to human psychology of interpreting information known as Gestalt principles. We will take the same public transportation example to understand how Gestalt principles help us create visuals that are easy to interpret at a glance, even in high foot traffic environments like bus stations. Gestalt principles explain how humans naturally perceive and group visual elements. There are 5 basic ones. Let's look at them one by one. 1. Proximity. We see objects close together as related. In a bus schedule, grouping times next to the route name conveys they belong together. 2. Similarity. We group objects that share similar features, color, shape. If each bus line uses a distinct color or icon, riders quickly spot their route. 3. Continuity. We follow continuous lines or curves. On a transit map, a single unbroken line helps users trace the entire bus path. 4. Closure. We fill in gaps to see a complete shape. Even if a station icon overlaps part of a route line, the user perceives it as unbroken. And 5. Figure ground. We distinguish the main figure, the route line, from the background, the station map. High contrast ensures the route stands out. Additionally, there are 3 aspects which further shape user perception. 1. Size. Larger elements demand attention first. 2. Color. Distinguishes routes or highlights urgent information. And 3. Position. Prime real estate is typically top left or center in left to right reading cultures. Imagine how Gestalt principles will be applicable in our transportation use case. Group eastbound routes together with a red theme, westbound with blue. Show each road as a single, unbroken, color-coded line, even if it bends or arcs around corners. Make the route line thick and bold on a simpler, subdued background map. Large font size for station names, smaller for substops. Color-coded lines for each route, consistent from kiosk to app. Position the real-time arrival screen where crowds gather so it's unmissable. So, let's find out how will this improve user experience? This approach sets commuters at ease, quickly orient to find out information system, is also easy to use for someone new in the city. So far, we have seen what is needed to create great user experience. Now, let's see how to do it through a practical step-by-step approach. Now, let's apply these UX fundamentals and Gestalt insights within the design thinking framework while improving our city's public transportation system. We will go through these phases: empathize, define, ideation, prototype, and test and iterate. For an easy understanding of these concepts, we'll take one technique from each phase, providing an immersive, real-world look at how solutions evolve. So, without wasting much time, let's get started with our phase 1, which is empathize. The empathize phase seeks a deep understanding of user behaviors and frustrations. We will select user interviews as one of the techniques to connect with various commuter types, office workers, students, seniors, and possibly tourists. Interview will uncover how people find routes, what info they trust, and their biggest struggles. Let's see an illustration through hypothetical questions and answers. Question: tell me about your daily commute. Any specific routines or tools you rely on?
I check a local transit app, but it doesn't reflect real-time delays well. I rely on social media groups to see if the bus is running late.
What's your biggest frustration with the current bus system?
Inaccurate schedules, forcing me to either rush or wait aimlessly. The station map is messy. Lines overlap and I can't see where transfers happen.
If you could instantly fix one aspect, what would it be?
A reliable countdown timer for arrivals. Color-coded route signs so I'm not hunting for tiny text.
If you could describe a recent time you missed or nearly missed a bus, what happened?
I arrived 5 minutes early, but it left earlier than posted. No notice. I was at the wrong platform because the sign was unclear.
What type of updates or communication would you find most helpful?
Push notifications on my phone if a bus is delayed. A big live arrivals screen in the station, so I don't have to guess.
Thank you for your inputs.
Thank you very much. I hope someone listens to our problems here.
So, give a deep thought and note down your observations. Key takeaways from user interviews. We interviewed 2 users. Persona 1, office worker who needs timely arrival, real-time bus updates, minimal stress. Persona 2, college student who needs easy station navigation, quickly adapts to changing schedules, visually clear route markers. If we have to summarize all observations for our next phase, here are those. And unpredictable schedules. See unclear signage. No unified info channel. Our frustration with mismatched data. By empathizing directly, we see the true commuter struggles. Next, we'll define the problem more precisely with define phase. So stay tuned. In the define phase, we synthesize interview data to isolate the core problem. Let's demonstrate this through affinity diagramming technique, which groups related insights and labels them for clarity. Few insights from our earlier phase. Real-time updates. Once accurate countdown. Missed bus due to outdated times. Station design and signage. Map overlapping lines. Confusing platform labels. Communication channels. No official alert system. Checks multiple unverified sources. Now, let's follow these steps. Collect data, transfer notes, quotes onto sticky notes, group similar notes. Discuss and label. Name each cluster. Identify top user frustrations or highest impact issues and create an affinity diagram for users. Here is how our affinity diagram looks like. So, what is our final problem statement? Commuters need a reliable, visually clear, and updated way to find bus info so they can minimize waiting times, missed connections, and route confusion. Now this gives us a laser-focused objective for the ideation phase. Stay tuned. In Ideate phase, we produce multiple potential solutions to a given problem statement. We will use Scamper framework to find potential solutions. Scamper is a creative thinking framework designed to spark fresh ideas or refine existing products, services, or processes. Each letter in the acronym represents a different prompt. S. Substitute. Consider replacing parts, ingredients, or methods in your idea or product. For example, using a new material or swapping roles in a process. C. Combine. Explore merging elements or functionalities. For example, blending two products into one or combining tasks to save time. A. Adapt. Think about modifying an existing solution or drawing inspiration from another context. For example, adopting strategies from different industries. M. Modify. Consider ways to alter size, shape, or form. This can include magnifying, making something larger, grander, or minifying, shrinking, or simplifying. P. Put to another use. Envision using an existing component or process in a new context. For example, retooling a machine for an unexpected purpose. E. Eliminate. Identify which elements can be removed to reduce complexity, cost, or inefficiency. For example, cutting steps that don't add value. R. Reverse or rearrange. Reverse or reorder steps in a process, or flip an idea upside down to discover new possibilities. For example, rethinking the sequence of operations. By systematically applying each prompt, Scamper helps teams break out of habitual thought patterns and generate innovative solutions. Now, let's apply this framework to our public transportation system and find out solutions to our problem statement. Substitute. Swap static timetable boards with interactive digital kiosks listing real-time arrivals. Combine. Merge kiosk data with a mobile app that uses the same color coding and route icons. Adapt. Adapt airport departure boards to show each bus route, next arrivals, and gate platform. Modify. Enhance station signage with color-coded routes, distinct icons for express versus local buses. Put to another use. Use bus shelters as community info hubs, also showing weather or local event advisories. Eliminate. Remove text-heavy schedules. Rely on bold icons, minimal text, and real-time updates. Rearrange. Paint lines on the station floor from entrance to bus stands. For example, a green line for route 1, a blue line for route 2, etc. Through Scamper, we now have a broad set of ideas and some feasible options to implement. Our next phase is a prototype phase. In prototype, we choose the most promising ideas and create tangible drafts. We'll outline user stories for each persona, then produce low-fidelity sketches or wireframes, focusing on user flow, not polished visuals. Let's define some high-level requirements from our earlier phases. Remember our user interviews? Let's consider their key problem areas as the priority for us. So, what were those? Let's do a quick recap. User story from person 1. As a busy office worker, I want a digital kiosk that shows me bus arrivals in real time so I can avoid missing or waiting too long. So, what are those key features that this user is looking from the application? 1. Countdown timers. 2. Platform number. And 3. Push notifications. User story from person 2. As a college student, I want color-coded lines in the station and an app that mirrors those colors so I instantly know which bus to take. So, what are those key features that this user is looking from the application? 1. Visual route representation. 2. Minimal text. And 3. Real-time delays. Now, based on our understanding of the user stories, let's draw some sketches. Low fidelity. Sketches of a station kiosk. Now, we are entering into our last phase, which is testing and integrating phase. Test and integrating. In tests, we validate prototypes with real or representative users. We'll take usability test as our approach to demonstrate this phase. We will observe participants as they interact with our kiosk sketches, on flow markings, and app. Similar to how we did hypothetical interviews, this phase will be hypothetical too. Let's take 3 participants matching to our personas and distribute testing tasks to them. Task for person 1. Find next bus arrival for route 5 on the kiosk. Task for person 2. Follow the green floor line to your bus platform. Task for person 3. Use the app to see if there's a delay on your route. Expectations from these users are to document observations. For example, record how long each task takes. How easy it is to find information. Is a color-blind participant mixing up green versus red lines? It is important to note that there is no or minimal interaction with end users here, and the documented observations are based on the data generated through system, which is also called as quantitative test. But it is equally important to conduct qualitative test as well through direct or indirect feedback. For example, some people may give positive feedback like, countdown timer is so helpful. Some may say negative like, text is too small for the routes, or I didn't see an alert for a delay. But important is to document observations and refinement needs. For example, increase font size, add colorblind friendly palettes, highlight the alert button more. Testing helps us iterate, and the cycle continues. For example, based on our first phase of testing, we might revise kiosk layouts or introduce an accessibility mode with high contrast and bigger icons. This brings us to an end of all the design thinking phases. But wait. How was our public transport system before the session? And how it is now? I hope you have enjoyed this session so far. If yes, put it in the comment sections. In next section, we will talk about what a future of UX looks like according to me, and of course, the closing comments. Before we wrap, let's discuss how AI is already shaping and will continue to shape user experience. Predictive personalization. Machine learning algorithms can learn individual commuter patterns, offering tailored route suggestions or delay alerts. In transportation, if the system knows Ideate usually takes Route 5 at 8 a.m., it can push a notification. Route 5 is running 10 minutes late. Consider Route 7 as an alternative. Conversational interfaces. Chatbots and voice assistants can help users find schedules or answer station-related questions. A commuter might say, "Hey, station kiosk, when is the next bus to downtown?" and get a voice or text response instantly. Intelligent navigation. AI-based real-time traffic analysis can recommend faster or less crowded routes, could integrate with AR overlays on a user's smartphone to guide them through the station, or highlight the correct platform floor line. Emotion and behavior tracking. Future interfaces might use facial recognition or voice sentiment analysis to detect frustration and proactively offer help. For instance, a kiosk might sense repeated errors and prompt an on-screen tutorial. Need assistance? Tap here for a guide. Ethical and accessible design. As AI becomes more powerful, designers must address privacy, bias, and transparency issues, ensuring everyone benefits, not just tech-savvy riders. Accessibility remains critical. AI must respect user data and comfort levels. Now that we've explored UX best practices, Gestalt principles, design thinking, and the future of AI-driven UX, think about where you see the biggest opportunity. If you found value here, please like, subscribe, and share your thoughts in the comments. Remember, great UX doesn't stop at visuals. It's about empathetic solutions that improve real lives. Until next time, keep designing with curiosity, compassion, and an eye on the future of AI.